When we are doing reflections, okay, there's two different ways that we're going to reflect. One of them is over the y-axis. So this is kind of like what we talked about yesterday with the difference of, are we moving on the y or are we moving on the x, okay? This is a reflection across the y-axis or a reflection across the x-axis, okay? Here's how you tell. If your function is taking the opposite of x, okay, so f of parentheses negative x, so the opposite of x, this flips over the y-axis, okay? Notice here, you will only change your x, okay? It's the opposite of x. It's not the opposite of the function. It's the opposite of the x value. When this happens, if it's a line, which majority of the time it will be a line, this will be only the slope changes. And this will all make more sense when I show you in a real problem. So this right here is our y-axis, right? We're saying this figure flipped over and became this figure, okay? Notice the y values of those figures didn't change. Only the x value of it changed. This was a negative 3, 1. Now it's a positive 3, 1, okay? My y value isn't any different. It's just my x value that is different. Okay, but if we move across the way, and we take the opposite of the entire function, okay, so now it's not the opposite of x anymore, it's the opposite of the whole function. That one flips over the x-axis. Ooh, sorry. Okay, that's going to flip over the x-axis. In this one, the whole function is changed, not just the x value of it. So this one is going to change the y value of our function. So in this situation, your slope and your y-intercept will change. Okay, slope and y-intercept will change. Now in this one, you don't have a y-intercept, but notice this, for instance, okay? If we're flipping over the x-axis, right, here's my x-axis, that's what we're flipping over. Now what was the point 1, 2, 3, 4, 1, right? This was the point 4, 1. Now it's the point 4, negative 1, okay? So my y value is in a new spot. My x stayed the same, but my y value changes. Is that the health department? Put your mask on. Are they out there? Oh, lovely. Okay, so with that, okay, we are going to do a bunch of reflections. And these can be very simple as long as you keep them straight, okay? So I cannot stress enough to you, when you are doing this, f of negative x versus the opposite of x, f of x, you need to make sure you know, am I flipping over the y-axis or am I flipping over the x-axis? Because if you can just keep that straight, it's going to make a lot of sense, okay? Okay, so example 1, it says let g of x be the reflection of f of x equals 3x plus 3 in the y-axis, okay? So if we're flipping over the y-axis, what is changing? Just the x value, okay? So here's all you have to do with this. You're going to think of it like this. The new function, g of x, is going to be 3, right? So I'm using this, times the opposite of x plus 3. Well, that's really just saying g of x equals negative 3x, right? If I multiply this, it's a negative 3x plus 3, okay? So this right here will be my new function. Only the x value changed. So basically what happens is what was your slope becomes the opposite. right? Because if it's a negative x, we're multiplying that by that coefficient, that slope that we're working with. Okay, so if we're going to graph these, let's graph the original in blue, and then I'll graph the new one in that orangey red color. So my original function, to graph that, I'm going to plot a 3. 1, 2, 3 is my y-intercept, okay? And then I'm going to go up 3 over 1. So my initial line is this, right? That's the blue function. Now, the orangey red function, okay, this guy here, my y-intercept is still 3, but now where do I move for that slope? Down 3 to the right 1, right? 1, 2, 3 down to the right 1, and that's going to go here. Okay, notice what happens. If I fold that graph paper on the y-axis, those lines kiss each other, right? That's a reflection over the y-axis. Does that make sense? Okay. Okay, now we're going to take that same problem and we're going to, oh, there they all go. Fun. Ay, ay, ay. Who wants to be on the health department? That's just not a fun job.
How long are you going to be?
Always dealing with crabby people, I think. I have no idea. I don't know if they have any idea. It was just like, they're coming. Okay. Okay, so this next one, here's our original again, right? F of x equals 3x plus 3. Now we're going to reflect it over the x-axis, okay? Now we said this is it's taking the opposite of the entire function. So basically we're saying this, g of x, my new function, is going to be the opposite of the old function, right? Well, all you're doing really is changing the sign of every piece, every term that you have. So g of x is going to be a negative 3x minus 3, okay? So if that's our situation, I have to flip my page because I'm looking at the wrong thing. Now notice you have a different y-intercept and a different slope. So if we graph the original one, let's go here. Original one is up 3, and then we're going to rise 3 over 1. Okay, so that's that line. But now if we take this one, you have a y-intercept of negative 3. So now we're going down 3. 1, 2, 3. Oh, we're getting our little dots all over. Okay, and now my slope is down 3 over 1. 1, 2, 3 over 1 is going to get me that graph. Okay, notice now where the fold happens. If I fold my graph paper on the x-axis right here, right, those will match up perfectly. So we just reflected over the x-axis. So you just need to keep straight. If we're reflecting over the x-axis, change the whole function. Right? Positives become negatives, negatives become positives. If we're reflecting over the y-axis, then you want to change just the x. Okay? Okay. So look at example 3 there. It says, let g of x be the reflection of f of x equals x minus 4 in the x-axis. What are we changing? Everything, right. So that means the rule for g of x, okay, this is part A, the rule for g of x is going to be what? What's the new equation if we're changing the whole function? Is it what? Right. And you may do it like that to start, but then make sure you always simplify. I don't have to see that part of it from you. You can do opposite of x and opposite of that negative 4, and that is your new rule, right? Now, if you want to start with it like this, g of x equals the opposite of x minus 4, and then distribute that negative, that's fine, okay? But I don't need to see that step from you. I just need to see this, and then we would graph both of them. So the original looks like this, okay? down 4, 1, 2, 3, 4, and then your slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. I kind of missed, right? My new function, I'll do that one in this pink color. So that's a y-intercept of a positive 4, 1, 2, 3, 4. And then negative 1 means down 1 over 1, down 1 over 1, down 1 over 1. So we get this line. Okay, so just think x-axis, change it all. Y-axis, only change your x value, which is a little tricky, right? You wish they would do that for the x-axis, but y-axis, you're just changing your x. Okay, you try number 4 for me. It says, let g of x be the reflection of this equation in the y-axis. Write that equation. What's the new equation going to be? What'd you get? G of x equals what? Negative 2x plus or minus 5? Plus 5. That stays the same, right? The only thing that changes is your x value. So it's a negative 2x plus 5. Okay, so if we graph this first one, I'll do it in blue. Up 5, 1, 2, 3, 4, 5. And then with a slope of 2, we're going up 2 to the right 1. Okay, so that's our starting graph. Your new graph, this guy, we're going to start same y-intercept, a positive 5, but now down 2 over 1. Okay, looks like that. Questions on that? You good? Yeah, Zoe.
Okay, so just another rule. So y is you change just the x, and then for the x-axis you change everything.
Everything. Yep. Over the y-axis, just change the x. Over the x-axis, change it all.
Got it. Okay.
Yep. Okay, last thing. It says let g of x be the reflection of f of x equals 7x. What is a function rule for g of x if it is shifted up 5 units and reflected over the y-axis? So now this one's a little bit fancy, right? What does it mean if we're going to shift it up 5 units? So think back to yesterday. If we're shifting it up 5 units, what's your new equation? Forget about the reflection right now. What would it be if we shifted up 5? 7x plus 5. Okay, so let's take f of x and shift it first. 7x plus 5. Okay, so that's just we went up 5 units. We want to know what is g of x, the new function, if we shifted it up 5, which we already did, but now reflect it over the y-axis. What does that equation become? Yes, negative 7x plus 5. So only your x changes if we reflect over the y-axis. So this would be your equation. And we're not going to graph that one, but that's what it would look like. Okay? So reflect over x. What do you change? Everything, right? Think of it this way. An x is like a big cross out. We want nothing. Cross it all out. We want to change it all, right? Reflect over the x-axis, change everything. Reflect over the y-axis, what changes? Just the x value, just your slope, essentially, will be the opposite slope. Okay? Questions on that? All right. That is it. Just a heads up, you guys have a quiz on Friday. That will be 2.5 through 2.7, okay? There's a chance I won't be here tomorrow just because my daughter's sick and my husband has stayed home with her 2 days in a row, so it might be my turn. But she might be just fine, and then I don't have to stay home. So just a heads up, if I have to teach you 2.7 via a video, I need all of you to promise me that you are going to watch said video and do it the right way, not just like, oh, free day, teacher's not here, because I subbed for those classes where people are like, yeah, we're not going to do it, she's not here. Do it, because you have a quiz on Friday, okay? No excuses. I will record a good video if I'm not going to be here. But hopefully I'm just here and it's all good.